Hello friends, welcome to the second video on construction of analytic function using Milne Thomson method. What we did in the first video was we tried to find out what is the analytic function f of z if we are being provided with the real part u or with the imaginary part called as v. We followed 4 steps for it. First, if u is given, then we found out the partial derivative ux and uy from the given function u. Then we associated the variable x with that of z and y with that of 0 to find or form the new functions phi1 of z comma 0 and phi2 of z comma 0 from my ux and uy, and then I went and substituted this derivatives in my f dash of z, which is ux minus iuy. So it became f phi1 of z comma 0 minus I times phi2 of z comma 0. From my derivative f dash of z, I was able to get my f of z by integrating the functions with respect to the single variable called as dz. This was when u was given. And now when v was given, we did the same thing, but ux is equal to vy by our CR equation. And so the format for your f dash of z becomes v with respect to y plus I times v with respect to x. You can notice that the derivative is first taken with respect to y and then with respect to x, rather than that of your u, where first it was with respect to x and then was with respect to y. And the second thing to observe is when u is given, there is going to be a negative sign in center, and when v is given, we have a positive sign in center. So now for the given v, we found the derivative first vy and then vx, so that vy now corresponds to my phi1 and vx corresponds to my phi2. Now substitute the same formula, x is replaced with that of z and y moves with that of 0 to find the new functions phi1 and phi2. Now put it back in your f dash of z with vy, the first derivative with respect to y in the first position and v with respect to x in the second position, integrate it to get your f of z. So this was the type of problem which we covered in our first video. Now moving on to a level higher than this. What we have is f of z is equal to u plus yv is an analytic function, and we have been given with u minus v to be equal to e power x times cos y minus sin y. So we have been asked to find f of z in terms of z. So rather than giving either a u independently or v independently, what happens over here is we have been given as a combination of u minus v. So this Milne Thomson method which was given over here has to be slightly modified for it to make it applicable for this kind of function. So we will see how this can be proceeded now. Over here, what I am taking is f of z is going to be my given u plus iv. I am just multiplying this with I, so that I times f of z becomes iu, I into I becomes minus 1, so this becomes minus v. Now I have a f of z and then I have an I times f of z. So what I am going to do is I am going to add these two quantities. When I add f of z plus I f of z can be taken outside, so that it leaves with 1 plus I. When I add my right hand side, what happens is the quantities which is going to be independent of I, that is my real part, now becomes u minus v over here, and the quantity that involves I will become u plus v. So this is what is going to be the expression which I have. Now if I assume the quantity which is going to be your f of z into 1 plus I by my capital F of z, and I assume my u minus v as my capital U and this u plus v to be equal to capital V, then what happens is I get a new format called as f of z is equal to capital U plus I capital V. Now I can notice this u minus v which has been given in our question now becomes the real part of my capital F of z. And if the question says suppose asks you if u plus v is given, then that will become my capital V of my capital F of z. So now what all things which we did over here to my function small f of z, the same thing can be carried out for my capital F of z. So that is going to be the process in which this problem is going to be executed. So keep in mind, so what is going to be my given capital U now? So this quantity is going to be equal to, I have my u minus v given. So I am assuming this to be equal to my capital U, which is a part of my capital F of z's real part. So this is going to be my real part of my capital F of Z. So now what happens next is I am going to apply Milne Thomson method in a similar fashion to this and do the same thing. So what happens in my Milne Thomson method? Step 1. So in my step 1, for my capital U of x comma y, what is your capital U of x comma y? Which is going to be my u minus v, which has been given as e power x into cos y minus sin y. So this is going to be cos y minus sin y. My step 1 is nothing but compute your capital U with respect to x and your capital U with respect to y. The derivative of U with respect to x and U with respect to y. With respect to x, cos y minus sin y remains as constant, and e power x alone on differentiation gives you e power x. With respect to y, e power x remains constant and cos y on differentiation gives you minus sin y, minus sin y on differentiation gives you cos y. So my step 1, finding the derivatives ux and uy is over. What is going to be my step 2 of my Milne Thomson method? I am going to assume my dou u by dou x, which was with respect to x comma y, to be a function phi 1 of z comma 0. That is, wherever I have x in my derivative, I replace it with z, and wherever I have y, I replace it with 0. So what happens in my u of x? I replace x with z. So this will become e to the power of z into cos y. So this will become cos 0 minus this will become sine 0. So my phi 1 of z comma 0 will be equal to e power z cos 0 minus sine 0. What do we know about cos 0? Cos 0's value is going to be equal to 1. And what is the value of sine 0? Sine 0 is 0. So this now happens to be equal to e power z. So I have got my phi 1 of z comma 0 to be equal to e power z. Similar fashion for my the first derivative, u with respect to y. In terms of x comma y, what I will have to do is, I replace it with function phi 2 of z comma 0. So that is, my x is replaced with z and y is replaced with 0 in my u with respect to y. What is my u with respect to y? So this is going to be e power z. So this becomes e power z. And what happens over here? Minus sine y. So this becomes minus sine 0 minus, this is going to be cos y. So this becomes cos 0. So now I have this to be equal to e power z into minus sine 0 is going to be 0 minus cos 0 is assumed to is taking the value to be equal to 1. Hence, when we apply the quantity over here, this becomes minus e power z. So my phi 2 of z comma 0 becomes minus e power z. So I am done with my step 2. We move on to step 3, where I replace f dash of z to be equal to phi 1 of z comma 0. For u, it is going to be minus I times phi 2 of z comma 0. So, but the change over here is, it is not capital small f dash of z, but rather I have changed it into capital F. So what happens over here is, I will be dealing with capital F dash of z rather than my small f of z. So keep this in mind. So what will happen to my capital F dash of z? Now this gets replaced as phi 1. What was my phi 1? My phi 1 was e power z. So I have e power z minus I times of, what is my phi 2? Phi 2 is going to be minus e power z. Okay, so this is going to be my f dash of z for me. So when I going to take my e power z common outside, I am left out with 1 plus minus of minus will make it as plus, and this is going to give me I. So my capital F dash of z is going to be e power z into 1 plus I. So now I move on to my step 4. What is going to be my step 4? My step 4 is obtaining my capital F of z. How to obtain the capital F of z? It is integration of capital F dash of z with respect to dz. So this capital F dash of z is integral. What was the F dash of z for me? This is going to be equal to e power z into 1 plus I times dz. With respect to z, 1 plus I is a constant, so you take it outside so that we are left out with just e power z dz. And what we know about e power z on integration, that leaves us with the same e power z. So now my capital F of z is the analytic function which I have obtained to be of the format 1 plus I into e power z. But our aim was to obtain small f of z. What was the relationship between small f of z and capital F of z? So we will go back to check what was the substitution which we made. We made that capital F of z into 1 plus I equal to my small f of z. So what happens over here? This capital F of z is capital F of z is nothing but my small f of z into 1 plus I. So this capital F of z is small f of z into 1 plus I. So this value is now equal to 1 plus I times e power z. Now cancelling this complex number on both sides, what we are left out with is that my small f of z is the function e power z. So I have obtained my analytic function in terms of z, and what is the required analytic function? It is my e power z. So this is the way we proceed when we have been given with either a u plus v or a u minus v. So we will try to do one more problem of the category u plus v. So the problem is, if u plus v is x minus y into x square plus 4xy plus y square, f of z is equal to u plus iv. We have to find f of z in terms of z. Again, notice we have not been given with a single u or single v, but we have been given as a combination of u plus v. We will go back to check out with the process. So if u plus v is given to me, I have to assume it as capital V of my capital F of z. So that is my imaginary part of my capital F of z, which was formed from my small f of z by multiplying 1 plus I. So this is going to be the process we are going to follow again. So I am going to copy paste the same. So we will refer this for our having it as a reference. So what we have is f of z is u plus iv. I multiply with I and I add these two equations, which leaves me with u minus v plus iu plus v. I take this f of z into 1 plus I as my capital F of z, u minus v as my capital U, and u plus v is my capital V. In which case, the quantity which has been given to me is my u minus v. Where is my u minus v? My u minus v is taken as my capital V. So what I have been given is my capital V. I will have to apply Milne Thomson method for my capital V. So we will proceed with this. So what is going to be my step 1 in it? So for the given function, what is going to be the given function for me? U minus V, which is taken as my capital V, has been given as x minus y into x square plus 4xy plus y square. My step 1 is going to be finding the derivative v with respect to x and v with respect to y. So I am going to compute partial derivative of v with respect to x. And so this will be equal to differentiating partially with respect to x. Keep x minus y as such. Differentiate your second term with respect to x. So this gives 2x plus 4y and the y square becomes 0. Plus keep the second square x minus plus 4xy plus y square as such, and then you will have to differentiate the first term with respect to x. So this becomes 1 and y becomes 0. Next, I go for the derivative v with respect to y. So with respect to y, keep your x minus y as such, differentiating the term with respect to x, 0 plus 4x plus 2y. So the second term will be x square plus 4xy plus y square into x minus y on differentiation with respect to y gives you minus 1. So my step 1, which is derivative, is being got. Step 2. What is my step 2? I am to fix my phi 1 of z comma 0 and phi 2 of z comma 0. We need to keep in mind phi 1 of z comma 0 is the derivative with respect to y. So this is my dy. What is phi 2 of z comma 0? This is my derivative with respect to x. In the derivative, what we'll have to do is replace wherever I have x with that of z and wherever I have y with that of 0. So we will start replacing the values. over here, x is replaced as z, y is replaced as 0. This will become 4z plus 2, 0 plus this is z square plus 4 into z into 0 plus y square is becoming 0 into minus 1. So let me simplify it. It is z into 4z. This will become 0 plus this will become minus over here, and you have z square, and this will become 0, this will become 0. So I have 4z square minus z square. So that makes it as 3z square. So I have got my phi 1. What is my phi 2? Phi 2 is in Vx, you replace your z comma 0. So come on, we will begin. Z minus 0 into 2 times of z plus 4 into 0 plus the next term z square plus 4 into z into 0 plus 0 into 1. This vanishes, this vanishes, this vanishes. I have this as z into 2z. So it becomes 2z square. And what happens over here is plus z square. So I have it as 3z square. So I notice that my phi 1 of z comma 0 is 3z square. And my phi 2 of z comma 0 is also 3z square. So my step 2 is over. We move on to my step 3. What is going to be my step 3? I know that my capital F dash of z is my phi 1 of z comma 0. Center sign is plus I times phi 2 of z comma 0. My phi 1 of z comma 0 was 3z square plus I times 3z square, which was my phi. So 3z square can be taken outside as common, leaving you with 1 plus I. So this is my capital F dash of z. What is going to be my step 4? My step 4 is computing capital F of z, which is obtained by integral of f dash of z with respect to dz. So this is nothing but integral 3z square 1 plus I integration with respect to z. 1 plus I is a constant, take it outside. 3z square on integration gives you z cube divided by 3. 3 can be cancelled off. So my capital F of z is equal to 1 plus I times of z cube. What is the relationship between capital F of z and small f of z? I know that capital F of z is small f of z into 1 plus I. So on equating, I have this 1 plus I to be equal to 1 plus I into z cube. Cancelling the complex number on both sides, what I am left out with? My analytic function small f of z is equal to z cube. So I have obtained my analytic function f of z in terms of z. So whether you have been given a u plus v or u minus v, you can follow this second methodology and apply the same Milne Thomson method to get your answer in just 4 steps. Thank you.